Hello everyone and welcome to today's video on data structure interview questions on Intellipaat. Do you know friends that data structures are fundamental concepts in computer science that organize and store data efficiently? They provide a way to manage and manipulate data, thus allowing for optimized access, insertion and deletion operation. Common data structures include arrays, linked lists, stacks, queues, trees and graphs. Each data structure has its unique characteristic and is suited for a specific use case. Understanding the data structure is kind of very crucial for developing efficient algorithm and solving complex problems. By choosing the right data structure, developers can enhance the performance and scalability of their programs, thus making it easier to manage and process large amount of data. Now before we move on and begin our hands-on session, I request you that do not forget to hit the subscribe button and click the bell icon.
So let's start with arrays. And our question is, given an integer array nums, move all the zeros to the end of it while maintaining the relative order of non-zero elements. So guys, this is a very interesting question. So let us see how to solve this question. So suppose we have an input array called nums and we have this number something as 0, 1, 0, 3 and 12 are the elements. So how the output we are expecting is something like this. So 1, 3 and 12 are coming at the front and all the zeros are shifted at the right end. So let us consider an array such as, suppose we have an array, say array name is nums, okay, and we have this much number of elements 0, 1, 3, 0, 12, okay. So what kind of output we are expecting here is that all the zeros like this one and this one should be shifted at the right end. So our answer will become something like this. So this is our required output. One other case you can think of something like this. If nums is this kind of an array, so we have elements all over here, such as you can say all the zeros are at the left end only, and we have the elements such as 1, 2 and 3. So our output would become something like this: 1, 2 and 3, 0 and 0. So guys, you would have got a clarity that what is expected in this question. So you have to move the zeros at the end of it while maintaining the relative order of the elements. Okay. You can pause the video right now and think of an approach that how you are going to approach this problem and solve the existing problem. Okay, so this can be your first approach. You can think something like this. So suppose we have this array nums and I put the elements such as 0, 1, 3, 0 and 12. Okay. So what can we do all over here? That we can create a vector. Okay guys. So we can create a vector, okay, name as duplicate. And what we're gonna do it that we're gonna insert the elements 1, 3 and 12 by iterating over it, over the entire array and leaving the zeros behind. What you can do, we can create a vector and put all the elements in this vector called duplicate, which are non-zero elements. Okay, so this is the first approach. So suppose, so here the number of elements is n, okay, and suppose in our duplicate we get m elements. Okay, so what we will do, so suppose in our vector duplicate we got this element as 1, 3 and 12. Okay, so if we find out the relative difference between these two, so if we go for finding relative difference between the vector duplicate and this array called nums, so we are going to get what are the difference of elements is missed by duplicate, and we can insert all those elements. So suppose if I say 1, 3 and 12, so suppose we have nums has number of elements nums has is around 1, 2, 3, 4, 5, okay, and our vector duplicate has around 3 elements. Okay, so what is the difference here? So nums minus duplicate equals to 5 minus 3 equals to 2. So means we are missed by 2 zeros. So we can insert 2 zeros in this duplicate vector. So this becomes our answer. So guys, I hope so you could have found out this approach. It's a pretty simpler one, but the problem is in the question asked, the question stated that you have to move the elements at the end of it. Okay. So we are performing our operations using some other array or a vector, which is kind of not required. It is actually not expected. The interviewer could say you, please try a different approach. I don't want you to take any duplicate array. I want you, all the operations or your approach should just involve using one array. So how we can solve this problem by just using one array? You can pause the video guys and then think of a very good approach or any approach which solves the problem. I'm going to take certain approaches and tell you that how we are approaching. The only thing to be understood right now here is guys, how we are trying to solve this problem. What is our approach? We will see at the end of it when we have found out the solution that how is the right way to approach a given problem. So there is a note for you guys in the above approach why I'm discarding that, So actually what we did was we took an extra space actually, which was like order of n. So which is kind of not an optimized approach. So whenever you are sitting up for an interview, when your interviewer is going to ask you certain questions, so when he says that this approach is not optimized, so you have to find out a solution how you can optimize your algorithm or the way of your approach to solve the problem. So that was that in the above scenario, our approach or our was not optimized. So let me give you another approach in which we will be trying to solve the problem. So guys, what our approach can be something like this. Consider this as our first, the red marker which is all over here is a first zeroth element. And this orange one is our first non-zero element. Okay, just remember these markers. So what I'm going to do, something like this, I'm going to construct our array and I'm going to swap these first zero and first non-zero elements. Okay, so our array would become something like this. This is after first operation 0, 0, 3, 12. Now we are going to place our pointers. So our first 0 right now comes here and our first non-zero element is around here. Okay, so after swapping, because remember we have to swap first non-zero. Remember we have to swap first zeroth and second non-zeroth element. Pretty much fine. Okay, so after this operation our array would become something like this. Okay, 1, 3, 0. So we have to find out our first zeroth element. The first zeroth element is all over here. Okay, and there is one more 0 which I missed it out. Okay, I'm going to add it up. Okay, so our first 0 element is all over here and after first non-zero element is all around here. So what we are going to do, we're going to swap them. Okay, so our array would become something like this. 1, 3, 12, 0, 0. We have found a solution, but in this we are taking 2 pointers, and guys, I would say this is pretty complex approach. You would be also feeling how we are going to create 2 pointers and this swapping operation. The approach is correct. There is no doubt about it. You could go with this approach and code it up if you are able to, but I would suggest that the coding can be a little bit complex for beginners. So this approach could be avoided, but if you want to go with this approach, this is also pretty much fine. Okay, so I would suggest that let's try to find out some other easier way to solve this problem. You can pause a video and you could think about some other approach. So guys, I hope so you would have thought about something. So here's another approach which is pretty efficient and pretty interesting. Okay, it's a very amazing approach which I would always recommend to use it in these types of questions. So suppose we have an array and I would say I'm saying iterating from I equals to 0 to I equals to n. Okay, so here we have an array called nums and I am putting 2 counters, that is I and j. Okay, I would say that I is somewhere around the first non-zeroth element. Okay, this is I, and j I would initialize as the first element. Okay, so we are traveling from I equals to 1 to n basically. Okay, so here is our array called nums and this is the element 0, 1, 0, 3, 12. Okay, we are initializing all over here. I equals to 1, okay, and j equals to 0, okay, the first non-zeroth element basically, where it is present. Okay, now what we are going to try to do all over here is that whenever, okay, so whenever we are finding the first non-zeroth element, so we are going to replace the value of the ith index to the jth index, and we are going to increment the j, something like this, guys. So at the first step would be something like this. So here is our first non-zeroth element, and here is our, the counter of j. Okay, so we found our first non-zeroth element, so I'm going to replace it by 1 1 0 3 12. Okay, this was our step number 2. Then again we increment the counter, so our counter I becomes here and j becomes here. Okay, since it's encountered a 0th element, so we are gonna do nothing and we are gonna just increment the I at this stage. Okay, increment the I. So at the second step, our array would be still the same, 1 0 3 12. Okay, our ij is still at this position, but our I will be at this position. Okay, now since we have encountered a non-zeroth element, so we're gonna replace it all over here, 1 3 0 3 12, and our j position would be shifted to all over here, and I would be at the end of the array. Okay, so basically I has traveled from at this distance to the end of the array. Okay, so what we are gonna do is, still we are finding the non-zeroth element, so I'm gonna replace this with this element, okay, and increment the j. So our array would become something like this, 1 3 12 3 12. Since I has completed its iteration, okay, I will be here, and j would be incremented. Okay, so we can find out right now that we have almost traversed, or we have moved the elements all around from 1 3 12, and j is at this position. Okay, so when we have traveled, when I has traversed the entire array, so what's the value of j's are left, means j at index, what the index of j is left. Okay, so here it is like 1 2 0 1 2 3 4. Okay, so j equals to 3 all over here to j equals to 4. We're going to fill these elements a of j and a of j plus 1, okay, with zeros. Basically, since there are two elements only left, so I'm just saying, just giving you an example, that a of j plus 1, or the leftover elements like this and this, since we have to traverse till here, so we're going to fill these elements with 0. So our array would become something like this. So our answer would go something like this. At our final stage, it will be 1 3 12 and 0 0. This is a pretty optimized approach, and I hope so, like some of you would have thought about it. Okay, if you have prior solved this question, it's very good, it's kind of revision for you, but this is actually one of our approach which actually I wanted to discuss. So we went on to 3 approaches. Okay, see, we are not arriving at our solution. So whenever we are facing any new question, we are not expected to instantly write the most optimized code. Your approach should involve hit and trial method. Okay, this is the one thing which you have to learn it. So basically you learn by hit and trial. Okay, so first you're going to do wrong, or you approach some easier way, then you will think, okay, how to optimize this, or how to add the element, then how to add some flavor to your approaches, and then at the end of the day, after too much of trials, you get to solve the question. So now it's time for us to write the code and see how we are writing the code for the same. So guys, here is a code, and you could try to hit on your systems. So it will be something like this. So we have found our code, and we are going to try to write the code in a language you could choose like C++, Java, but I'm choosing actually C++. So it is my personal recommendation that for solving data structures, you could go for Java or C++. So this code is written in C++. Okay, so what the first thing we have to do? So we have to move the zeros at the end of it. So let's just create a function. Okay, so our function is void move zeros, and in this I'm gonna pass 2 parameters. Okay, the first one is a vector and second one is the array. Okay, So I'll say vector int and nums. So I'm gonna basically initialize the size of the array. Okay, so how we can do it? So there's a very good way. You could just declare a variable and put it nums dot size. Okay, so that's a one good approach. So there's int n equals to nums dot size. Then I initialize j. Okay, so int j equals to 0. Now let's traverse the array. Okay, so I'll start with the for loop. For int I equals to 0, int I less than n, and I'm incrementing it with I plus plus. Okay, so if nums of I is not equals to 0, so I'm telling it a condition that here, that if the element we have encountered like in the earlier is not equal to 0, it's a non-zeroth element basically. So what I'm gonna do right now, I am gonna replace it with the element at the index j position. So nums of j equals to nums of I. Basically I'm assigning the position. So and then later on I'm incrementing the, you can say, the position of jth, okay, or incrementing the jth, that would be right to say. Then I'm closing the loops. Okay, next thing what we are doing all over here is, then what we are saying that when for till then, suppose j has reached till, say there was 3 and 12 left in the element, and 1 3, there was also 12. So j was at here. So we're going to start from the jth position where jth has entered till then. So for here again for loop, because I want to change the values to zeros. So for j, so just this you could do, and j less than n. Okay, and I would say j plus plus, and I'm gonna say all the position which are left out after I has traversed entire array. So I'm gonna put it to 0. So nums of j equals to 0. Hence it solves our problem. Okay, and this is the complete optimized code. Okay, so let's look at the code once again. So for our better understanding, so let us find out the first thing the first thing what we did all over here is that first we tried approach. Okay, we got an approach in our mind, and we also figured it out. It is a kind of an optimized approach. Okay, so what we did was that first, in order to solve that approach, we are going to first create our function which is going to solve our problem. So here what I say is our function is the first thing we created. Okay, coding is nothing, guys. The language is just a kind of a language to interpret about your thoughts, what you want to do. Okay, we created an array, we pass out the parameters. Okay, it's very important for you to pass an array. Okay, and this is the size of the array. Here we are calculating, and I've initialized already that here j will be here, here I will be here. So I've initialized j equals to 0 because j should be starting at the first index, which is at the 0th position. Then I am traversing entire array. Okay, so for traversing, what we are doing here, guys, we are applying the for loop. Now here is a conditionals. Okay, because we had a condition in our approach that if we come across the non-zeroth element, basically, which is written all over here, what we're gonna do, we're gonna assign the value of the jth index, nums of j equals to nums of I. Okay, and we are incrementing it with j plus plus. Okay, got it? And then what we are doing is basically the leftover j's, just put all these values to 0. Pretty simple code, guys. It is not a complex code, but that approach earlier, which I told you about putting 2 pointers and going again and again, so that could have been a little bit complex, but see, this approach is pretty much consistent. So guys, I would have thought like this is a pretty easy approach, and you would have understood how we approached a problem. So we are not learning here how to solve arrays question. So that should not be our agenda. Our agenda for today's session should be like how we are approaching a problem to solve it. Because believe me, when you're going to sit for the FANG companies or any good MNC, they're going to ask you questions and which will be pretty new to you. So, and you cannot learn all those questions, you cannot solve a lot of questions, and it just does not works out. You cannot learn a code, So my only advice to you should be, guys, that first start with pen and paper, try it, try to solve it, and come out of with some approach. Try to find out what flaws it has. Is it taking extra space, or its complexity, time complexity has increased? So with that thing in mind, always write a optimized code. So guys, I hope so you would have understood how to move the zeros at the end of it. Now let's move to the next question. So our next question is of sorting. Okay, this is also a pretty interesting question, and we are definitely gonna learn something interesting and something new. So if I read the question, it says, given an infinite stream of integers, find the kth largest element at any point of time. We have a note here that we have a stream instead of a whole array, and we are only allowed to store only kth element. Suppose if someone asks you find the kth largest element, okay, so you would have some output and some input. So let me just explain to you what kind of input will be there and what kind of output we are expecting. Okay, so k is any parameter, you can consider it, k equals to 2, k equals to 3, and at the kth position. Okay, for that problem the k is not going to change, and if someone inputs the value of k, so your output for that stream of integers, the kth largest element, should always be coming out. You should always produce those output. As first, something I would like to tell you that this is not an array. This is infinite stream of integers. So how you can expect this as a problem? Suppose there is a data stream which is coming to you. Okay, consider a lot of number of data. So each time a data gets added up in your array. So that is kind of an infinite stream of integer. Let us solve the problem and let's see what kind of approach do we have. Okay, so guys, like in this whole problem, what it is trying to say is, suppose these are the operations. Okay, so for every kth largest, when we are asking, there is an add operation going on. So this is our initial array. Okay, and we are adding these elements. Okay, so basically what we are doing is, let me show you. Okay, so suppose this is our array. Okay, and I'm saying that suppose in the input section I'm putting k equals to 3, and we have all our array as 4, 5, 8, and 2. Okay, so I'm asking which is the kth largest, which is the third largest element. Okay, so the third largest in this, as you can see, the highest one is 8, next one is 5, and the third one is the fourth. So we have to return 4. Okay, similarly, if we had added one element called 3, okay, so 4, 5, 8, 2, 3. So which is the third largest again. For every kth largest operation, we are adding one element. Okay, so here one element is added, like suppose here 3 is added. Now we are asking which is the third largest again. So the first largest is 8, second one is 5, and still our third largest comes out to be 4. So I'll be just putting something like this. So the answer, what we are returning. So it's step 2, we return something like this. In the third step, one element again gets added. Okay, it says 5, and our size of the array has increased. Okay, now if I'm asking which is the third largest, okay, so it's 5, then 5, then 8, then 4. Okay, so third largest most precisely in this, if we are not considering the duplicate elements. Okay, if we are even counting the duplicate elements, so there is no uniqueness, so our third largest would come out to be a 5. It could be either one of them. Okay, so that's one thing. Okay, so in this way we are expecting to solve the problem. Okay, so let me just give you an pictorial view. Okay, I hope so you would have got a brief idea about this problem. So let me show you one approach how you can solve this problem. That one is called min heap approach. Okay, let us create a minimum heap and store these elements, and we could pop out the element maintaining the relative order of the heap. So how you're going to maintain the heap? The size of the heap, okay, should always be equals to k. Okay, this one is pretty interesting question. So guys, please be with me. Okay, so now let's come up here and add the first element. Here is 4. Okay, since we are not satisfying the size of k, so we are going to add one more element, that is 5. Okay, 5 gets added here. Then we are adding the third element like 4, 5, and 8. Okay, now at this position we are satisfying our, you can say, somewhat the kth largest scene. Okay, we can find out, since our k is 3 here, so we can say we can find out the third largest because we have the 3 elements all over here. Okay, so what is our third largest element? It's 4. Okay. Let's see this. Now let's go on to the next stage. Okay, for every kth largest, okay, we say we add one element. So here one element is added, that's called 2. So let's add it up, okay, since we are just ending our array. So you can see all over here that the size of the heap is not maintained. Size is not equals to the value of k. Okay, this is a scene here. So what we're gonna do, we are gonna pop the topmost element, okay, in order to maintain the relative size. So here we get 4, 5, 8. Okay, so our element returned as a kth largest is 4th. Okay, now let's add another element called 3. Okay, so here 3 is added, so our heap size is increased. It is not stable, so we're gonna pop the topmost element. So here this element, we're gonna pop it up. Okay, so after popping it up, our size of the heap becomes consistent. Okay, so we can say the kth largest element here in this case return here is 4th. We are returning the topmost element, and at the same time we are popping up the topmost element in order to maintain the relative size of the heap. Okay, then we add up one more element called 5, 4, 5, 8, 5. Okay, so in this case what we are going to do, we are going to pop the topmost element in order to maintain the relative size. Okay, so now this gets popped up. Okay, so we can see here in this case, now the value of the kth largest element is changed, and our in this case the kth largest element is 5. So we are adding the element and our kth largest element is changing, so the value of k is consistent throughout the problem. So here our heap is 5, 5, 8. We add one more element, that's 10. Here 10 gets added up. Okay, we have added 10. Now the size of the heap is changed, and we have popped out the topmost element. Okay, here's a pop operation. So after popping up, our heap becomes 5, 8, 10. Okay, so what we are going to do, we are going to return the topmost element. So now again at this position we are adding one more element. Okay, that is called 9. Okay, so I'll perform an operation, add 9. Okay, so our size of the heap is not consistent here, so we are going to pop up the topmost element. So our heap becomes 8, 9, 10. Now it says we have to add 4. Okay, so suppose we are adding one more element 4 here, but you should skip this because the answer would be same. Okay, 8, 9, 10, because if I create another picture, say here 8, 9, and here is 10, and here you say one more element comes of 4. So but ultimately in order to maintain the relative size, we will pop up this, so which is pretty much not expected. Okay, so you can skip this up. So this was all the problem, and this was one of the approach how you can solve the problem for infinite stream of integers. Okay, suppose a data stream is coming up consistently. Okay, that's a hit populating your array. Okay, but every time you are asking the question, to your function that please return me the kth largest, and kth value is not changing throughout. You can fix k equals to 5, k equals to 4, k equals to 3, but once you have fixed it up, your value of k is not changing for that input. Okay. So let us delve into the code and let's see how we can solve this problem. Okay guys, so this is the code. Okay, so let us inspect this code and let's see how well it fits in our approach. Okay, as said, we are going to create a priority queue named PQ, and there are certain number of parameters I have taken like int, vector int, and gint. Okay, let's see the entire logic inside this function, what basically I'm doing. So I've set a variable, this is a global variable, so I've set it equals to k. Okay, so basically k is equals to the kth largest element. Okay, and I'm trying to traverse inside this array called norms. Okay, filling this element. If pq dot size is less than k, okay, so there is a one condition which I'm putting up. This is a very important condition. Okay, so suppose if the size of our heap, okay, say it was 4 and 5, and our k equals to 3. So if PQ, if the priority key or the size of this heap is less than this, then only we have to push an element called x here. Okay, this code says something like this. Else if there's second condition which says if PQ dot size equals to k, okay, and also x is greater than PQ dot top. Okay, this is second condition, which means that, so in the last scenario what we found out that we had this 8, 9, and 10. Okay, this code demonstrates that scenario. It says that the size is equal to 3. Okay, our heap is maintained, but x is should be greater than the topmost element, otherwise it's no point of pushing that element. Okay, we will be wasting the time, performing the same add operation, because if we add 4 here, so what's the point on returning the kth largest? Our kth largest is not changing. So when our kth largest is not changing, we have to also give a condition here that if the element added should be greater than the top element, then only I'm going to push. There are true conditions. The first one was this, that the size should be less than, okay? And the second one was that the topmost element should be greater than the, the element added should be greater than the topmost element, okay? Now let's see the another operation, which says that if pq dot size is greater than k. Now suppose we are in this scenario, okay? Suppose it was 4, it was 5, it was 10, it was 8. So this is a pop operation basically. Okay, so pop operation, what's saying that if the size is greater than k, we are not maintaining the heap. So we are gonna pop the topmost element. Now I'm gonna say that add function is all over here. Okay, so in the add function, what I'm passing a value parameter. Okay, so in this value parameter, what I'm saying that I have to add the element. Okay, now I'm adding, suppose say our size is maintained all over here, and I have to add an element called 9. Okay, void add 9. So in order to add 9, I am passing this parameter called val. Okay, and I'm saying that if pq dot size is less than global was equals to k. Now I wanted that variable to pass on to this function also, so I just made it as equal to k, and I'm telling that if the size is less than the global is less than, then I'm pushing the value. Okay, basically, and if pq dot size is greater than global, then I am performing the pop operation. So basically this was the same code which we have copied and pasted from here, but with different global variables. So same parameter of adding, it is pretty much easier this time to comprehend like how this addition operation is happening, because if you would go once again to that diagram, okay, let me just show you that in this scenario what's add operation, suppose 10 has happened. Okay, so in this we are saying that the size is greater than k. Okay, so we are popping it up. Okay, so two operations are happening at the same time. First, kth largest is being called, and second one you have to add it. So adding a value or an element and popping up at the same time. Okay, so we are adding 10, 10 goes down. Now we are calling which is the greatest largest. Now here is a one condition that the size of this is greater than so pop operation is happening, which is written in the last code. And in this case, in order to add an element, so what we have written all over here in this code is this, that pq dot size should be less than global. So push the value. If the size is less, okay, suppose in the add operation initially, so the size, basically the size of the priority queue, if the heap is also less, then you should add the value or push the value. Pretty much simple, guys. This was a pretty much easier approach and a good problem to understand. So what at the end of the day, what I would suggest you, that sit up with pen and paper. Okay, try to solve at least 5 problems in a day, and when you are trying to find an approach or trying to go for a hit and trial approach, it's pretty easy, it's pretty good. I would say it's very good to make mistakes, but it's not good that if you are not trying. So just seeing the solution won't solve your problem or won't give you a way of analytical thinking to solve a problem. Solve as much problem as you can, but try to solve by yourself. Then you will figure it out what is the optimized way to solve the problem. So these were few of the interview questions, some of the mid-level interview questions, which was asked in the interview. I hope so you would have got a fair idea how to solve a data structure interview questions, which was kind of a hands-on one. Okay, so these were the code. So that was it for today's session. Thank you for watching this video, guys. I hope so you would have enjoyed our today's video on how to solve data structure interview questions on Intellipaat.
Just a quick info, guys. Intellipaat offers advanced certification in data science and AI in collaboration with iHub Divya Samparka IIT Roorkee. Through this course, you can learn all the important concepts of data science and AI from esteemed IIT Roorkee faculties and industry experts. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given below in the description and take a first step towards career growth in field of data science and AI.